Welcome newcomers. This is my modded Ender 3. It's been my go-to 3D printer since 2019 and it's been on quite a journey. I've used it to print out so many things, ranging from printing a full-sized BB-8, no R2-D2 yet, to a full-size Daft Punk helmet, all on this one Ender 3. Since it's open source, there's a massive modding community that is great for making this printer yours, much like I did here. The joys of being open source means anything goes for customization. It means this printer can grow with you, making it a great test bed for features you want and might want to implement on a more expensive printer, and a great way to learn what you need and want out of a 3D printer. My goal was to make this printer as plug and play as I could. Here are my favorites from easiest to most involved. First, I swapped out the stock tube with this Capricorn tube. It comes in a pack of 3 and will be long enough that you would have left over from one piece. The stock one was just minimal quality. It didn't handle PETG too well either and got really messed up after I printed parts for the Daft Punk helmet, so I swapped it with this. They are made of Teflon so it can handle the max heat output by the Ender 3 without any issues. I swapped out the plastic extruder end, put an all metal extruder. After using the printer over the course of the year, the plastic extruder began to break down due to the friction of the filament coming into the bowden tube, causing the bowden tube to come off in the middle of a print. While you could 3D print it over and over again, I'm lazy, so I went with an all metal end. Again, this is one of those things that Creality cut corners on to hit a low price point. This metal end is also a dual gear end, which smooths out filament output to the extruder. I installed a set of aftermarket springs and knob. Before these springs, the bed needed regular adjustments between print, especially after these 20 to 23 hour prints when I was printing BB-8. This made the printer retain its level far more often, where I only had to adjust it once a week if I was doing those 20 plus hour prints over the course of several days. I got tired of struggling with removing prints off the printer bed and having supports prematurely break off in the removing from the bed process. On several occasions almost cutting myself with a scraper, so I upgraded to a glass bed. It makes leveling easier since by its very nature, it's perfectly flat. Unlike most other materials, it doesn't get dented or bent out of shape the way the stock magnetic bed did, nor does it expand as much as other materials do. It lacks adhesion, and there are a few ways to mitigate that, ranging from glue stick to tape and even hairspray. I use bed weld to make sure prints stick. While not a hardware hack, it may as well be. This stuff is like magic. When you coat a glass bed with this, it's amazing. Preheat the bed and shake the bottle well, then apply it to the bed and let it cool down. Then you're ready to go. It heats up and the coating makes sure that the print sticks to the bed better than using glue or tape does in my experience. Then when it cools down, the print just comes off. No need to use a scraper most of the time. While it does work with the stock bed material, you'll get a lot of flaking that doesn't occur on glass for some reason, meaning you won't need to recoat the print bed as often. It's also less of an issue for cleaning than glue or spray, just needing to be wiped down with some soap and then it can be recoated. No nasty residue or stickiness left. I use an X-belt tensioner as well. After a couple of months running this printer with back-to-back prints, the gantry cable started to loosen up and this fixed it right away. I have one for the bed in anticipation for it becoming loose over time, but it hasn't happened yet. Now we are on to the more fun involved stuff. Installing a BL Touch. This is the device used to self-level the bed. Yes, you still need to adjust the printer head with the knobs at the bottom of the bed, but a BL Touch will significantly reduce the need for this. I haven't had to adjust this printer in months because of this. It does mess up from time to time with the plunger not retracting the right way on rare occasions, but other than that, it's a massive time saver. You're going to need to upgrade the firmware on the stock Ender 3. This is going to require opening up the printer and using a special adapter to connect the board to your PC and flash the firmware using Arduino IDE. You can get the firmware from the official link on GitHub or Creality's site. Be warned that this could be a major headache and you run the risk of breaking your printer's motherboard if it doesn't go right. That being said, it's probably the biggest change you can make with the printer before diving into a big hardware change that arguably makes it a different printer altogether. Manually load the extruder to the bed using a piece of paper to measure the gap. If the paper catches a bit, then you are good. Otherwise, manually lower it a bit more. I also use these feeler gauges that are used in machining. Not necessary, but a nice thing to get. And it's usable for other things like CNC. I use an aftermarket all metal hot end for this printer. The reason I swapped this out is because over time the stock hot end failed on me at the nozzle end due to wear and tear, and the hose end wouldn't seal properly. It also has the added benefit of being able to deal with more abrasive materials like carbon fiber, being more resistant to wear and tear in general, and cools down much faster than a stock hot end, making careless mistakes when working on printers in the middle of the night while you're half asleep less likely to result in you getting burned. Also, don't forget a good cleaning kit along with this special filament you can use to clean out the printer when you are swapping filaments. Just preheat the nozzle to the higher range of temps that the filament you are using has and push this cleaning rod through the nozzle end to remove the clots, if they happen. Preheat the printer to max and use this filament to push out leftover filament from previous prints when you're planning to switch from something like PETG to PLA. Remember that there are still remnants of the plastic in the nozzle after the spool is removed, and switching from PETG to PLA may cause the printer to not even start since the PETG has a higher melting point unless you clean out the nozzle first. After the plastic comes out clear on the nozzle side, just push through some of the filament you intend to use and let the printer cool down to the ideal temperature for the filament. This will prevent the printer from leaving cleaning filament in the hot end. As painful as a process as this is, there are only a few ways of doing filament swaps. Either use this method, have a dedicated printer just for that filament, or have solvable hot ends that can be dropped into place for certain filaments. PETG is my go-to material for making visors or domes via vacuum forming because you won't need to go 100% infill the way you would do with PLA. Honorable mention is this slotted wrench. This thing fits between the gantry and the extruder when you need to tighten it up without much of an issue. It also works for tightening the metal bit at the extruder end or the bottom of the bed. A silent board is by far the most complicated part, yet it has the most killer features, most of which I haven't taken full advantage of yet. As the name suggests, it lowers the noise produced by the printer. Don't ask me how. It also allows for more robust features to come into play like filament runout sensors and touchscreens, provided you want to spend the money on those. I don't use a filament sensor here because I keep this printer in my home and not my workshop, so I suppose if you keep your printers elsewhere, it would be worth it. This board can allow you to completely customize your printer. You can run custom Marlin firmware or Clipper. It can also manage noise even more, turning off the fans completely when the printer is idling, which I don't get why Creality doesn't do this by default, but I guess it saves money on the R&D side of things. Now, why didn't I do certain mods? Mostly because I didn't need them. While silent fans and screen covers are nice features, I have the luxury of keeping the printer where it doesn't bother any of the people in my home. I also didn't want to add handles because this printer doesn't get moved often. Didn't put in any of those rail guard things because after I switched over to bed weld and the glass bed, I didn't really have filament falling into them. I didn't use any of those extender things for making a bigger printer because I may as well buy a larger printer. Finally, I didn't add Octoprint because I couldn't manage multiple printers with it, and I'm not a fan of time lapses, though I might use it at some point down the line. That's not to say I wouldn't add these in at some point, but for now the printer is as good as I need it to be. Also, I didn't add in something like a direct drive because, well, I'm just cheap and lazy. Even after all these mods, I would still say this printer is perfect as an entry-level device without adding a single mod to it. The price to performance ratio is just unbeatable. What seals the deal is the size of the bed. Out of all the features I think kills people's interest in 3D printing, it's bed size. It often stops people from making any of the cool things they think about with 3D printing, like Iron Man helmets or Daft Punk helmets. Being about 13 inches, 332 millimeters diagonally, means you can print large things between 2 and 3 pieces like I did with BB-8. Granted, each panel took 40+ hours. You would also learn a lot about 3D printing from modding and maintaining this printer than you would with a less modded printer, and will save yourself a lot of money if you figure out that you don't like 3D printing that much. There you have it. All the mods I put into this printer. Over the years, I just wanted to get this printer to the point that I can hit print and it consistently goes. I don't expect it to need zero maintenance. I didn't want to need to recalibrate between every single print. I didn't want to struggle trying to remove the print off the bed, and I didn't want to baby the printer needing to keep an eye on it at all hours. I wanted to treat it as a tool for making cool stuff and not the cool thing to mess around with. While it's pretty good as it is, I still have a couple mods I'd like to put on this printer someday. Maybe a filament runout sensor because those runouts after a 28-hour print is just depressing. printing. A hot swappable hot end would be great because it wouldn't have to clean the hot end if I changed the filament out, and I could just have a couple of printers instead of several for when I need specialized hot ends for printing certain things. For now, I like it as it is. It's a really reliable printer, and it hits my goal of being easy to use and requiring low maintenance.